This is my robot arm that I built to protect my gears of my servo. Watch what it does. Click, click. It hits the switch. Back off. Goes back again. And continues doing it. That's not a stop. That's a stutter. This week, I built the safest feature. Broke it twice. Fixed the bug that was sitting in my code since the very first commit. And still ended up reverting my whole code. Let's go through it. 2 micro switches, one on each mechanical stop, wired into ESP8266. The moment this servo drives into a press switch, the firmware is supposed to cut power instantly, not ease it down, cut it, because the continuous rotation servo has no idea where it is. Any ramp is still torque against the hard stop. First version worked, slow motion review, and looked terrible. The stop was visibly abrupt, which is correct for safety, but felt wrong for a build that's supposed to move like so, not a solenoid. So I went looking for a something soothing function I was already using somewhere else. And that's where it got interesting. Every ramp moved in. This firmware called a function expecting one thing and pressing it another. The second parameter I would call rampMs. For weeks, I assumed it was milliseconds. It's degrees per second. 90 degrees swing at the number I was passing took about a second and a half to actually finish easy. My test script was resending commands every 150 milliseconds, faster than the ease could ever complete. The server looked broken. It wasn't broken. It was still mid-ramp from where commands ago. I only caught it because a complete different test script on the various speed instead of holding one value. Rotated the arm just fine. Same servo, same wiring, different command pattern. That's different is what cracked it open. Swapped to the correct duration based call and real motion came back. With the real motion restored, the emergency stop revealed a second bug. When the switch trips, the firmware reverses pulse to back off to stop, but my test script was still resending drive commands during that pulse, and every resend was retriggered the trip handler from scratch, cancelling the retreat before it finished. The arm never actually got a clean window to back away. That's the click from the code open. I patched it. Once the trip starts, the firmware ignores every incoming command, including stop, until the retreat finishes on its own. Rebuild and it compiles clean. Patched the fix. Tested it on real hardware. It still didn't hold up. And at that point, I made a call to Revert rather than keep stacking patches on a safety critical function. I couldn't fully verify it without a switch in front of me failing a different way each time. This week 33, not a clean win, a real bug fixed. That easing mistake was genuinely wrong and stay fixed. But the trick response layer on top of it goes back to the drawing board, rather ship a honest rebuild on a fix. I only believe works because the terminal output looked right. A safety feature that made the failure worse before it got better. A bug older than the feature build on top of it, and an honest rebuild instead of fake fix. Subscribe to see whether next week's rebuild actually holds or whether the limit switch teaches me one more lesson first.